Hi, this is Nick Agram. In this series of videos, I will be discussing logarithms. But before I'm going to discuss logarithms, I'm going to remind you that there are a lot of inverses in mathematics. For example, the inverse of A, for example. The inverse of that is negative A. Sorry for that. And if we have, that is in addition. In multiplication, we have A. The inverse of that is 1 divided by A. So that here you can get identity, which is 0. Here, identity, which is 1. And when we have exponents, for example, then we have the inverse of that is roots. So if we have exponent and roots, they are inverses. Now we have exponential. The inverse of that is logarithm. Okay, so if I'm going to show you an exponential function, that is y is equal to b raised to x with a base b, and then the inverse of that is x is equal to b raised to y. But we are not allowed to put x in the left hand side of the equation, actually. So what they did is that they expressed this in y, but it is a logarithm of x with a base y, a base b, sorry. So that means they are inverses. This one is the exponential function. The inverse of this is the exponential. The logarithmic function. If I'm going to show you the graph of that is here. So the blue one is the exponential function, and the pink one is the logarithmic function. So if I'm going to change the base, it doesn't matter what the base is. As you can see, they are the mirror of each other. So as you can see, they are inverses. They are mirror of each other. That's the reason why we said that. Okay. But if I'm going to make this the inverse of this, if I'm going to make inverse of logarithmic function, then it should be the exponential function. But if I'm going to express this one, this, as an inverse now, then I know that it is x is equal to logarithm of y with a base b. So they are supposed to be equal, these two. 1 expressed in logarithmic, and 1 expressed in exponential function. So this is a very important definition. A function y is equal to b raised to x if and only if x is equal to logarithmic of y with a base b. I will give you an example of that using the base 10, which is a very popular one. This one. A very popular logarithm in base 10. For example, I'm going to write it here once again. Y is equal to b raised to x if and only if x is equal to logarithm of y with a base b. We change that y is equal to 10 raised to x if and only if x is equal to logarithm of y. We don't usually put base 10 there. Everybody understood that if there's no base, then it is 10. Okay. Let's take some example. For example, I have 1000, and that is 10 raised to 3. They are equal if and only if we have 3 is the logarithm of 1000 with a base 10, according to this definition, according to the first definition that I have. Okay. Another example, I will continue with that. For example, we have 100, that is 10 raised to 2, if and only if 2 is equal to logarithm of 100. I will stop using the base 10 there. As I've said, if I don't write, or your teacher doesn't write base, that means it is base 10. Then we have 10 is equal to 10 raised to 1, if and only if 1 is equal to logarithm of 10. And this one, I'm going to show you later that it applies to any base. That means if I have logarithm of 10 with the base 10, if I have the base and my y, if they are the same, then it is always 1. I will show you that later. Why? Because the exponent is 1 there, as you can see here. And then if we have 1, that means 10 raised to 0. That means 0 if and only if 0 is the logarithm of 1. This is also a very good property to know, that logarithm of 1 is always 0. It doesn't matter what is the base. Okay? I will show you later about that. So I hope you understood. And then if we continue, 0.1 is equal to 10 raised to negative 1. I use the comma, which we are using here in Sweden. 0.1. 0.1. That is 10 raised to negative 1. Then we have if and only if negative 1 is equal to logarithm of 0.1. I'm helpless with this. As you can see now, 0.01 will be 10 raised to negative 2 if and only if negative 2 is equal to logarithm of 0.01, and so on. Okay, now we're going to see if this applies. Oh, we have example here first. Without using a calculator, find logarithm of 100. As we said, logarithm of 100 is the same as logarithm of 10 raised to 2. So the exponent there will be your answer. Okay, like what we did here. This one. This one is 10 raised to 3. This is 10 raised to 2, 10 raised to 1. That's your x. Okay. The other one, logarithm of the fourth root of 10 is the same as logarithm of 10 raised to 1/4, laws of exponent. Then it will be 1/4. Okay? I hope you understood. And then in my next video, I will be discussing logarithm in base b. Any base. That is what I mean. If the thing that I discuss here can also apply in any base. Okay, see you around.